The single-line diagram of the model is as follows. The DER resource constituted by the station is connected to the upstream network at the ECP1 point. It includes the 3 DERs that are EVCs, which themselves include the 3 DER that are constituted by vehicles when they are connected. An HTA/BT station with 630 kVA power and ZS impedance supplies a cable from the BT board, point A. This cable feeds an industrial zone of charge S2 between points A and B, then our station at point B consuming a power SD, and finally a tertiary zone consuming S3 between points B and C. Other cables powered by this source from point A consume sexed power. The AC distance is about a mile. For the simulation, we evaluate the power consumed by the station and deduce the voltage VD at point B. The power sext, S2, and S3 are set for discharge at the minimum consumption of the station and for the charge by its maximum charge. The Zamiran model uses, from the point of view IEC61850, 7 IEDs of 3 models, 1 charging station model IED, IEDCS. 3 IEDSE model IEDs that differ only by the EVSE identifier. 3 IED-EV model IEDs that differ only by vehicle identifier. The station's IEDCS IED contains for logical devices, LDCS, which includes the station's basic LN, LN for schedules and LN for the DER aspect. It also contains proxies of the 3 EVSE. Each IEDSE IED contains 2 logical devices, LDEVSE including basic LN, schedule LN and DER-LN, and LDEV including some proxies LN of the potentially connected vehicle. Each IED-EV contains a LDEV1 that includes the vehicle's basic LN, schedule-related LN, and DER-related LN. Some operating data is transmitted through the report control block mechanism of the IEC61850 from the vehicle through the EVSE to the station and LEMS. The LEMS sends 2 schedules to the station. FSCH1 is periodic and daily, it is the basic program. FSCH2 is non-periodic. It is related to momentary problems on the upstream grid. The station sends to each EVSE a part of each FSCH according to an allotment key. When a vehicle plugs its cable into a EVSE, the EVSE sends it the schedule in service. When a change in the schedule in service is observed by the station sends this information to the EVSEs, which order the transfer of the in-service schedule in the connected vehicle Schedule 1. The vehicle Schedule 2 is reserved for the use of a schedule managed by the vehicle, meeting the maximum value imposed by the in-service schedule. At the station level, the DER power management function relies on the ECP voltage monitoring by the LNDVWC. It transmits maximum power, while charging or discharging, to the LNDPMC, which in turn transmits it to the LNDWMX. The latter finally sends a distribution of this maximum power to the LNDPMC of each EVSE. At each EVSE, the constraints on maximum power are developed by the DPMC according to the max sent by DWMX from the station, the capacity of the cable used by the vehicle, the maximum resulting from FSCH, as indicated by the FSCC. DPMC sends the constraint summary to the DWMX, who forwards it to the vehicle DPMC. At the vehicle level, the DPMC summarizes the constraints, coming from the EVSE, internal, from DSTO and DEEV. The LNDWMX receives the resulting stress and applies it to the power consumed or produced by the vehicle. Thank you for your attention.